So welcome all. Thanks for joining us for our August Lunch and Learn. I'm glad everybody could be here. Migration season somehow is upon us. Lots of Hawkwatch sites are reporting to hawk count. I know my site will start in another week or so here in New Hampshire. It certainly feels like fall weather. I don't know if everybody's having some cooler temperatures, which feels good, but it's definitely feeling like migration season here with north winds and cool temperatures today. I'm Julie Brown. I'm the Raptor Migration and Programs Director at HMANA. We are excited to welcome Marion Clément today from the Bird Conservancy of the Rockies. And she's going to be talking about saw-whet monitoring. I'll be facilitating things today with Kat Lauer. She's our administrative assistant at HMANA. And before we jump in, she'll be introducing Marion in a minute. Just a few things today to start off with. We always record our talks. We're going to be live streaming on Facebook, and you can view any of our past Lunch and Learn programs on our Facebook page anytime or on our website. We'll add our recording most likely in the week after the presentation. You can go up or scroll down to our What's New section on our homepage or under our Events and Tours tab on the top of the website. And I think we're up to date. All our previous Lunch and Learn presentations are there. And that's including last month's Will Weber's discussion about climate change and raptors. So adjusting your display on your screen, you can do that by clicking on the dots at the top of your right corner of your screen. We've disabled the audio and visual for video for everybody and found that's the best way to reduce distraction during our talk. So even though we're muted, we always like to connect with all of you. So feel free to put your questions into the chat, any comments throughout the talk. We love hearing anything you have to say, what you're seeing lately bird-wise, where you're tuning in from, what Hawkwatch you are joining from. And if you don't already receive HMANA's e-newsletter, that goes out once or twice a month. So you can add your name and email address to the chat, and I'm happy to add you. So with that, I'll turn it over to Kat to introduce Marion.
Thank you so much, Julie. Hi, everybody. I promise I am here. I'm having some technical difficulties today, so I won't be on video. But we are so grateful to have Marion Clément here to talk about her research on saw-whet owls. Marion has been working on raptor conservation and owl research since 2015. She began her work under the mentorship of David Brinker, one of Project Owl's creators. After helping Brinker with a barren owl nest monitoring study, she discovered her passion for wildlife. She worked as a wildlife biologist for 5 years in Maryland and then pursued a master's degree at Clemson University to study habitat selection of barred owls along an urban gradient. She first moved to Colorado in 2020 to work for the U.S. Fish and Wildlife Service on threatened and endangered species, and then joined the Bird Conservancy of the Rockies in 2022, working with Mexican spotted owls as their coordinator. On her own time, Marion started a Northern Saw-whet Owl banding station, and with the support of the Bird Conservancy of the Rockies near her home in Fort Collins, Colorado. Thank you so much, Marion, for being here today. Please feel free to begin when you're ready.
Yeah, well, thank you so much, Julie and Kat, for that introduction and for inviting me to speak. Can you guys still hear me okay? Good, perfect. It's a real pleasure today to talk to some other raptor enthusiasts about one of my favorite owl species, the Northern Saw-whet Owl. Quite frankly, it's maybe I'm biased, but one of the most charming owl species we have in North America. I've been doing research on this owl since about 2014, but as you'll hear today, I'm far from the only person doing this work. So the title of my talk today is A Tiny Muse in the Forest, How the Northern Saw-whet Owl Inspired a Tidal Wave of Grassroots Research, because I'm going to tell you about how this little owl inspired an amazing project that some of you may know called Project Owlnet. So an alternate title that I've used in the past is a tiny menace in the forest, because Northern Saw-whet Owls are ferocious little predators and are not to be messed with, as this one is clearly communicating to me. Northern Saw-whet Owls, as you'll see in many of my slides, have incredibly expressive faces. So before we get started, I'd like to take a quick minute to introduce myself and my organization. Bird Conservancy is a nonprofit. We're based out of Colorado, but we have staff in over 7 states across the Great Plains and the Rockies. Our mission is to work hard every day to conserve birds and the landscape they rely on, and we do that by bridging research with conservation efforts on the ground, as well as educational programs that ensure that future generations care about the stewardship of our environment. We've been operating now for over 3 decades, implementing projects in over 15 states. We have some great ways to get involved or to support our mission, so feel free to reach out for more information or to look us up. My role, as Kat said, at Bird Conservancy is primarily to coordinate several owl research projects, primarily our Mexican spotted owl monitoring program. And as Kat said, I'm also managing a Northern Saw-whet Owl fall banding station above my home in Fort Collins. So my work on Northern Saw-whet Owls began in 2014. I had just graduated from undergrad, and as many of us do in that time period of our lives, I was kind of bopping around from job to job, unsure of what to do. And I was really fortunate to land in Maryland's Chesapeake Bay Conservation Corps program. It's a really awesome early program that funds recent graduates to work on conservation for organizations up to a year. I got paired up with the Chesapeake Bay National Estuarine Research Reserve that's hosted within the Maryland Department of Natural Resources, so for that, the state government. And there, it really opened my eyes. I learned to drive boats in the marsh, tromp around in the marsh, surveying for plants, soil, water quality, and of course, wildlife. And I made some really incredible connections, including Dave Brinker, who's the state ecologist at Maryland Department of Natural Resources, and who also happens to have founded Project Owlnet, which is how many of us have gotten into saw-whet owl research. So I just wanted to quickly say that Dave is one of those rare people who prioritizes taking time out of his day to mentor eager biologist wannabes like me. And he took me under his wing and provided me with tons of other opportunities to work with different species, including barn owls, goshawks, pelicans, and waterbirds. So he really helped me grow in my experience as an avian ecologist, and I owe my career to Dave, as well as a few other special individuals who also mentored me during this instrumental period of my life. And of course, I owe it to the birds themselves who, let's face it, are absolute heartthrobs and really set the hook to my future path. So to me, it's rather unsurprising that the Northern Saw-whet Owls recently received the very prestigious Cornell Bird Academy Cutest Owl Award, and are often featured in media and books, like, for example, Jennifer Ackerman's recent books on owls. So no matter how you look at it, those bright yellow eyes on that tiny body really, really are adorable and capture the imagination. But what is surprising to me is that despite being this popular, Northern Saw-whet Owls are still one of the most poorly understood owls in North America. And I'll soon explain why, but a lot of it has to do with its ecology. So let's dive right into the star of the show. So Northern Saw-whet Owls are one of our smallest owl species. I believe it's the 5th smallest owl in North America. They are very secretive and hard to see. I would venture to guess that many of you on this call have never seen one in the wild, and if you have, you may have visited a banding station or gone on a birding tour with someone who knows about some good hiding spots. However, as elusive as they are one of the most widespread raptors in North America, as you can see from this range map. They prefer to breed in cool, moist forests, typical of boreal forests and coastal forest, as well as higher elevation forests like those found in the Rockies and the Appalachians. But in the winter, they've been found all the way down to the Gulf, and we really don't know how far south they go into Mexico. One noteworthy population is the subspecies called brooksea on the island of Haida Gwaii. And it's really unique. It looks different from the main species. It kind of retains the juvenile plumage with a very orange belly and a dark brown head. And there it feeds primarily on marine invertebrates. So that's pretty cool. Northern saw-whet owls are somewhat of habitat generalists. They are typically described to be found in coniferous or mixed hardwood forests, but this varies quite a bit across its range. So a better way to think of its habitat, in my opinion, is based on its needs, which are tree cavities for nesting. These are nest cavity obligates, as well as some winter cover in the form of typically evergreens like conifers and plentiful prey. I also wanted to bring attention to this fun next door post I saw on my feed. Last year, someone spotted a Northern Saw-whet Owl on their mailbox. If this isn't the best Harry Potter reference, I don't know what is, but we don't think of this owl as a backyard bird typically, but it does occur. And especially if there's plenty of rodents to feed on, which there are typically in urban areas. And so for example, I sold a mattress on Craigslist, and the lady who came to pick it up at my door found out I studied owls and loved Northern Saw-whet owls, and told me that she had actually seen one running around in her chicken run hunting the mice that were there to feed on the chicken feed. So they're quite adaptable little predators and just really flexible with their habitat selection as well. So speaking of predator adaptations, this owl has everything it needs to be a highly efficient hunter. It's got those very large eyes for night vision, so large, in fact, that there's no space for muscles to move them. This is typical of owls. There is a bony ring called the, I can never say that word, sorry, sclerotic ring, which is a bony ring that protects the eyes and also fixes them in place. And so that's why owls have to move their head to compensate, and they have twice as many vertebrae as mammals do, and they can turn their head 270 degrees. It also has a well-developed facial disc, as you can see in this picture, with those specialized feathers that amplify sound and vibrations, as well as some jet black, very sharp, by the way, talons, contrasting against the bright yellow foot pad. Northern Saw-whet owls, by the way, are cold hardy, and so they have feathers that go down the leg all the way down to the toes, which is pretty unique. They also have asymmetrical ears, and if you've never seen an owl ear before, here it is in the picture in the bottom right. As you can see, it's really quite something. It's really large. It's also unevenly placed on the head, and that helps the bird triangulate its prey. And it's lined with these additional bristles that almost look like eyelashes. All that makes the ear, the owl's ear, excuse me, a perfect design for really acute hearing. And this owl is strictly nocturnal and relies primarily on hearing to locate its hunting prey. And so it actually has hearing that's better than a screech owl and much closer to the hearing accuracy of barn owls, for example. Northern saw-whet owls primarily hunt small mammals, mammals such as deer mice and white-footed mice, but also shrews, voles, and house mites. So they're a very efficient pest control. And frequently they'll also consume bats, juveniles of squirrels and chipmunks, flying squirrels, and also some birds, especially during the migration, but that makes up a really small percentage of their diet, something like 1%. But really noteworthy is that they've been known to successfully hunt northern pygmy owls and robins and cardinals, which are about the same size as this owl. They will also consume invertebrates like beetles, cicadas, and grasshoppers. And again, that Brooksy subspecies consumes mostly invertebrates, actually. They are what's called a perch and pounce predator, very similar to our house cats. But they like to hang out on a low branch about 3 feet off the ground and just use that highly specialized facial disc to listen, triangulate prey, and then they come down hard on it and capture it. This is why you're unlikely to find northern saw-whet owls in a grassland or in a forest with no understory, as it needs those low-hanging branches to hunt. How much does it need to hunt? About 1 mouse a night is all it takes. That's about 17.5 grams, and it's enough to maintain its weight, although this highly depends on the season and whether it's migrating and so forth. Breeding for this owl starts in late winter and early spring. During courtship, the male advertises for a mate using its very characteristic territorial call. It sounds a little bit like a bus backing up. I've actually had someone confuse the call for an alarm. And I've actually got an example for you right here. Let me see if I can play it. Hopefully it comes out. Okay, I'll stop there. So for those of you that are familiar with owl calls, it actually sounds really similar to a northern pygmy owl call. But the main difference to me is that Northern Saw-whet Owls are rhythmically challenged and also tone deaf. They badly need singing lessons. So pygmy owls will be a lot more regular in pitch and tone, and Northern Saw-whet Owls are just, yeah, they're just a little challenged in their singing lessons. Northern Saw-whet Owls, by the way, like to switch it up. So every year they find a new mate. They do not mate for life like many other owls and other raptors. And the courtship involves often a gifted mouse, which might not sound like our kind of romance, but hunting success is very important in mate selection in raptors, because once paired up, the male is actually going to be feeding that incubating female as well as the chicks. He's going to do all of the feeding for both the female and the chicks. The male and the female, once paired up, will explore a few tree cavities, but the females get the final say. And those cavities are either going to be naturally occurring, so by disease, for example, or broken branches, or they're going to be excavated cavities by, for example, woodpeckers. They'll also readily take to nest boxes, though. But in general, as I said earlier, Northern Saw-whet Owls are cavity nest obligates, so they will not adopt stick nest or squirrel nest and things like that. And in case you didn't know, owls in general do not build their own nest, and they do not perform any maintenance. So they just pick something that's already available to them, and that's what they end up using. The eggs are laid in late February to early May, really depends on where they are in their range. And on average, the female will lay about 5 eggs, although sometimes she'll lay as many as 13 if prey is really abundant. The chicks will hatch about a month later. They'll leave the nest a mere 5 weeks later, and that's much before they've actually had the chance to fully develop their plumage and their flight feathers. This is a process we typically call branching. It's really common for owl chicks to leave the nest early before they're fully feathered because it's really hard to build flight muscles in the tight quarters of a nest cavity. During this time, they're really good at climbing trees, which is why it's called branching. They are fed by the male for another 2 months before they're fully on their own. And a fun fact is that they're rarely re-encountered in their natal area. Northern Saw-whet Owls have very low fidelity. They don't breed with the same mate. They don't return to the same nest area. And this really complicates things for us researchers. Okay. So as I said, Northern Saw-whet Owls are a really small owl, and they're about the size of a chicken nugget, which means that a lot of things like to eat them, including other owls, hawks, squirrels, outdoor cats, you name it. So their best strategy is to hide. And so during the day, they'll roost in really thick brambles and camouflage themselves among the leaves. And if spotted by an intruder, they'll assume a fright pose, which you can see here in this picture. They'll give you a really mean look, with raised feathers around their face, and look directly at the threat, and maybe even raise a wing up to their beak, but they won't fly away until the very last minute. So if you see one doing this pose, you are too close. So I've told you almost everything I know about these owls, which isn't much. So why the big mystery? Well, first and foremost, this owl is strictly nocturnal. So it's difficult to observe during typical surveys, surveys like the Breeding Bird Survey or IMBCR, the Christmas bird count, and so forth. In addition, people just don't love to be up past their bedtime. It's really hard to do red eye research. It's out of our comfort zone, and it's why owls are generally understudied. Because they are so small, in fact, the heaviest female will weigh about 100 grams. This means that in order to use GPS transmitters, which would be great to learn about, their fine scale movements, it's basically just a GPS that gets relocations at a set time interval and allows us to see where the bird is moving and hunting and roosting. But anyway, the transmitter and the harness must weigh less than 3 grams, which is about the weight of a penny. So that's pretty challenging to do with technology. And typically the way that we reduce transmitter weight is by substituting the battery power for a solar panel. And that just won't work with these owls, right? Because even in the day, they're spending a lot of time hiding in deep shade. So there's very few transmitters that meet this criteria. And lastly, they are nomadic. So they're a little bit like agents of chaos. They show no loyalty to their nest sites, their natal area, their wintering grounds, which means that we can't use a type of transmitter called a logger that are very lightweight, but require the researcher to recapture the bird and get the transmitter back to get the data. It's not communicating that data via cell towers or satellites. And so that's really hard to do when the owl never returns to the same place. I briefly do want to add that MODIS is a newer technology that seems to show great promise for these guys. And there's now over 500 birds that are tagged and efforts to deploy many more in the incoming years. But that's altogether a different talk, so I won't go into further detail here. So for now, banding data is still one of our best tools to study this owl. And I'd like to tell you a little bit about how banding started for this species. The legend goes that in the 60s, some bird banders accidentally left their bird nets open a little later than sunset and came back to find their nets dotted with little owls, sorry. And that's how we primarily found out that this owl was migratory, because up until then, the owl was believed to be non-migratory. Then in the 80s, Tom Erdman in Wisconsin did a little bit of investigating and discovered that these owls could be captured in really large numbers using an audio lure, which is basically a loudspeaker playing the owl's breeding call at about 90 decibels, which is loud enough to lure migrating owls down from the sky to investigate who this very large owl is. And that's the chart that you see up there, is the comparison of capture rates with no lure versus an audio lure. So you can see it increases capture rates by about 3-fold. So Project Owlnet began a decade or so later as more and more people caught the cute owl virus and started banding the Northern Saw-whet Owl. Dave Brinker was one of those people and got a taste of working with them in Wisconsin, and continued to ban Northern Saw-whet Owls when he moved to Maryland. And he realized that there was enough interest in banding this owl that we should probably standardize some of the work that we were doing. And that, of course, the more banding stations are targeting this owl, the more recoveries we would get and the more we learn about the species. So in 1994, he started Project Owlnet, which started off as a simple email listserv where people shared ideas, techniques, methods. Soon they added a website where they shared a recommended standard protocol and techniques. And this project grew very, very quickly and is now an impressive network of about 150 banding stations across the US and Canada and sometimes Mexico. Most of these, by the way, are run on the side by volunteers donating their time after work, often in the freezing cold, to get to shed some light on this owl of the night. So Project Owlnet is, it's not an established nonprofit. It's a loose collaboration of owl banders with no board, no sustainable revenue, aside from a grant that we recently received. More on that later. And just a few passionate individuals that are gifting their time to manage this project, including Dave Brinker, Scott Weidensaw, and now also Andy Brown, who manages our membership. Thanks in large part to the astronomical efforts of Project Owlnets and all of its collaborators, the number of banded saw-whet owls surpasses by a landslide the next most banded owl species, which is the barn owl. We now have this figure needs to be updated, over 400,000 individuals banded. It's really a gold mine of information from which we're learning a lot, but from which there's also still so much to learn. And there's some obstacles to doing this work, which I'll discuss a little later. But what we've learned so far, based on banding and recapture data, is that this species is highly migratory. Again, this was not believed to be the case originally, and that fall migration appears to be much more concentrated than the spring, which is why many of us only operate our banding stations in the fall. In addition, we learned how cyclical this owl's population is, with boom and bust cycles at roughly 4-year intervals. This can be seen in this long-term data plot of the total owls captured at Assateague Island, which is a station that Dave manages. This is believed to be primarily driven by cone mast years. So these are years when conifers all synchronize within a region to produce a very large pine cone crop. And this in turn boosts rodent reproduction, like rodents like deer mice and redback voles. And when there's tons of prey, the owls feast, they lay lots of little eggs, and they have really good fledging success. And so in turn, at our banding stations, we're flooded with tons of first-year birds. And this can lead to really stark contrast with some stations that typically catch about 200 owls per season, catching just 200 owls in one night. It really makes our day when this happens. Banding data has also been instrumental to understand migration patterns, particularly in the eastern US and Canada, where we have a lot more banding recoveries. The migrations, so this is pretty typical, are concentrated among mountains and water edges. But what's particularly notable is the way that Northern Saw-whet owls often seem to skip avian flyways altogether, as if they're navigationally challenged or perhaps a way to avoid high traffic. Living next to Denver, I understand that reasoning. There's lots of examples of this, but one example is a bird that was banded in Wisconsin and then found in North Carolina just 9 days later, showing that the birds crossed the Appalachians, which seems like a lot of effort for a reason that we don't understand. In the West, there's a lot more uncertainty in the migration patterns, mostly because we don't have enough banding stations collecting data out here. An example of that is that Western states have only contributed 6% of banding data since the 60s, and Colorado, my home state, only 0.3% of the banding data since the 60s. So for fun, I use this Audubon Bird Migration Explorer, which if you don't know this tool, I encourage you to explore it. But here I showed you a visual of the band recoveries that are in the Denver region, which is where I work. There's only 4 so far, none of them are mine. And they're shown here in black icons on the map. The red star is Denver, and the arrows are the 4 major flyways. And here we see some pretty straightforward recoveries in the northern Rockies of Canada, as well as one near Grand Junction in western Colorado, but also a surprising recovery in New York City. And this kind of thing happens all the time. What we're learning is that Northern Saw-whet owls have a really atypical migration where they mostly just seem to wander around with no fidelity to breeding or wintering regions. And last but not least, banding data can, of course, help us understand population trends so that we can direct research and funding should this species be in decline. This paper by Wall and al. Is one of the few publications tackling this topic. It used data from 7 long-term banding stations in the eastern US with constant effort and pooled their data together to look at trend over 25 years. And they found that populations appeared to be pretty stable, although they observed a slight decline. This is really informative, but it's missing a huge part of the species range out west. So there's still a lot more work to be done on that front. So why is it important to track trends in the first place? Well, I'm sure this audience doesn't need much convincing of that. We all know our world is experiencing rapid change from habitat loss, climate change, land conversion, and so forth. And all of that is occurring because of activities that are really critical to society's growth. So they're likely to persist in the future. How these changes are affecting Northern Saw-whet Owls, it's really hard to know. There's still so much we've yet to learn about the species. But we have some information like this climate report by Audubon that predicts a 72% decrease in the breeding range by 2080. That's the red regions on the map. So that's quite a bit, right? That's concerning. There's also a 52% range gained in northern Canada and Alaska, but the right tree cover and structure has to be present in those areas for that to be the case. And we still have a lot of uncertainty in our models about how these areas are going to change in the future and whether they're going to keep pace with the rate of climate change. There's also some narrow bands of stable habitat, like near my banding station in the Rockies, but it's not much. And so it's clear that although this owl is abundant and widespread, it is vulnerable to climate change. In addition, the forest that this owl heavily depends on, especially for breeding, are predicted to become less common in the future. Boreal forest, high elevation forest are modeled to experience really great loss. They're being hammered by insect damage, as you can see in the darker colors in the map at the top, as well as more and more severe fires each year. We're starting to learn that fire is really good for the ecosystem, but when we have these high intensity, high footprint fires that nearly have 100% tree mortality, this in turn affects temperature and soil moisture retention and can have some irreplaceable damage to the forest, where it's simply gone within our lifetime and beyond. And that's many generations of saw-whet owls. And lastly, disease outbreaks also seem to be on the rise. Warming climates are creating more favorable conditions for pathogens, as well as carriers like mosquitoes. The West Nile virus is an example of that and has been on the rise and is particularly lethal to young birds as well as to owls. There's been some disease outbreaks, like that of the West Nile virus, that probably had a pretty important impact on populations. An example of that is a very large outbreak in eastern Canada in 2002, where in subsequent years, we did not see the typical boost of owls we expected at our banding stations every 4 years. So you can see an example of that using the acetate data, where after 2002, we didn't see a peak for a while. We got one in 2006 or 2007. In addition, the recent strain of avian flu, which is called H5N1, is extremely lethal to birds in general. And we're starting to see it more and more in our raptor populations, particularly in eagles, because they eat waterfowl, and waterfowl are more impacted by this virus. This strain has almost no recovery rates across adult and young. It's a big concern for our raptor populations, including, sadly, our endangered condors, which recently experienced an outbreak, to our big surprise because they have no connection to waterfowl. But scientists believe that it was spread by finches that like to nest near condors for safety. Fortunately, our government recently allowed an exemption, and we started vaccinating condors. There's been a vaccine for a very long time, but it's not available to wild and commercial bird species for a number of different reasons, excuse me. So based on this information, it's clear that there's a need to assess trends for Northern Saw-whet owls. So what is the holdup? That's definitely what this owl is thinking. It's very mad. First and foremost, there's issues with compiling data because each banding station has their own times of operations, data structure, process for archiving data. And what that means is that data can't easily be compiled into a large-scale analysis without a tremendous amount of work first. In addition, other than banding data that's submitted yearly to the Bird Banding Lab, there's other very valuable types of data that we collect, such as effort data, for example. Effort data can be used to scale captures with the amount of time, nets and stations that are operating, and that data is stored by individual stations. So again, really hard to reach, but it could be instrumental to creating those robust analyses across stations with varying effort and timelines. Lastly, and maybe most pressing, is that there's a really great risk of data loss. Our data isn't centralized, and there's often talk in Project Owlnet of what happens if someone's barn burns down. This is a little bit of a joke, but it's not so far off because some of us have been banding for a very, very long time and store data on personal hard drives or paper copies. So what happens if that bander or hard drive is gone and we lose access to that data? Well, it's a huge loss to the project and to our objectives about why we ban birds in the first place. The good news is that we're actively working on fixing this. We've long realized that Project Owlnet has greatly outgrown its original objective, and that to maximize the conservation applications of the banding data that we have, we need to work together on standardizing it, archiving it, and with the approval of our banders of making it public so that it can be analyzed at a larger scale. This has been on Dave and Scott's mind for quite some time now. But it's hard to make progress when this is very much a side project and everyone is a volunteer. So when I joined Bird Conservancy of the Rockies, I saw an opportunity for our nonprofit to help with this amazing grassroots research project and to make some progress on this end. So Scott, Dave, and I worked together to apply for a grant from Tracy Aviary to support some of this work, and lo and behold, we were successful. So thanks so much to Tracy Aviary, as well as to some generous gifts from donors. We were able to get some of this work started. So one of our first tasks was to create a working group to lead this effort, and the working group is comprised of Project Owlnet members who bring a variety of skill sets to the table and also represent the wide regional footprint of our stations. We have 8 members who meet once a month to make key decisions to help keep things moving. And unfortunately, I'm sorry, I didn't have any pictures of my working group, so all 8 are represented here as owls. I'm probably, by the way, the one third row down on the right because I always feel like I'm in over my head. But Dave and Scott are probably the ones on the top right and the bottom left since they're so experienced and poised. I'll let you guess which owls are the other members of our team, but they include Andy Brown, Michael Oliveira, Anne Nightingale, Jeff Holroyd, and Mitchell Pruitt. And our working group goal in coming together is to create an updated, first and foremost, to create an updated list of our collaborators. So we want to know who all of the researchers are that are banding saw-whets. Believe it or not, we were doing this using Excel, and it's really hard to keep up with it every year. But we want to be able to increase collaboration across our stations and also show our reach. So we need to know where our banders are. So this work has already begun, and you saw a map earlier of these stations. The second goal is to put paper on pencil and to specify our mission, our short and long-term goals and priorities, and just define what it means to be an owl netter in the first place. And then our third goal is a really big lift, but we're already on our way to making progress on that front. We've been having some very exciting conversations with nature counts of birds in Canada about the potential to use their platform for this goal. And essentially what we want to do is create and populate a central data repository for Project Owlnet data so that we can archive that data and both past and future data, by the way, to safeguard it against potential loss, and to make the data accessible at different levels for future analyses as well. So all of this will be done, of course, with the feedback of our collaborators to make sure that we're capturing their broad interests and that we're developing a tool that they will actually use. So eventually, some years down the line, we also hope to facilitate the first range-wide analysis for the species with data from Project Owlnet contributors. This in particular is a very exciting goal because it's the key to assess how the species is doing, which we have very little understanding of right now. Should the species be experiencing declines like this long-term data set from Assateague Island suggests, these findings are going to help with the development of management plans for this owls and channel funds towards research and conservation. So hopefully I've portrayed just how important this work is and how much our volunteers have already gifted so much of their time to this owl that we care so much about. But ultimately, what we need to do is identify a more stable source of revenue to make this project more sustainable. So that was a lot of information to absorb. So I would like to end this talk today by switching gears and inviting you into my owl blind. Each year when the autumn wind blows and the temperature drops in September, I get very giddy, as you can see here, because it's time to ban Northern Saw-whet Owls during their fall migration. Over a cool little ridge overlooking my hometown in Fort Collins is a banding station that I established now 3 years ago with a small grant from Colorado field ornithologists and some money I set aside for fun stuff. I'm also grateful to say that Bird Conservancy is also now helping support it. We operate in this location from a humble ice fishing shack. It insulates us from the wind and the rain. We have a nice propane heater for warmth on those very cold nights, and it's really my home away from home from September to October. To catch owls, we use mist nets, which looks like a hairnet. Many of you are already familiar with it, but if not, they're stretched 10 feet high and 40 feet long. And we use the audio lure, which is the owl call that you heard earlier, broadcasted on a loudspeaker. So again, this attracts migratory owls that hopefully come in to investigate and get into our nets. And I want to say that the coolest thing about our station is that we're in this soft fabric blind, right? So not a ton of obstacle from hearing. And we're only about 100 feet from our net. So we can actually hear the owls come in and make all sorts of strange sounds like mews and yips as they grow frustrated trying to triangulate our very big owl. So close your eyes, imagine yourselves getting cozy by our gas burner. 30 minutes has gone by and it's time to check the nets, and we got an owl, which is very exciting. So what's next? Well, first we bring the owl back to our blind and we weigh it by gently placing it for a few seconds in this small Donald Duck orange juice can. You can't find those anymore, so they're highly sought after by Northern Saw-whet Owl researchers. We tare our scale, weigh the owl in the can, and owls, by the way, like many raptors, are sexually dimorphic. So there's no plumage difference between the male and the female, but the female is larger by about 20 grams. And of course, the mass can differ based on fresh meals, season, and age of the bird. But what we're trying to get to is how fit the bird is, how well it's fed. Next is a very important task, which is the whole reason why we do this work, is to outfit the owls with a federal band from USGS. The band has a unique ID that won't ever be used on another bird. It's like a social security number, and it's how we learn about it once it's hopefully captured again. So if you ever find one of these bands, consider yourself very lucky and report it, whether or not it's on a bird, because sometimes the bird gets predated and the band gets left behind. It contains very valuable information. Next, we measure the wing chord, which is just a fancy way of saying the length of the wing. It also varies by sex. Females have an average of an extra 10 millimeters longer on males. And armed with mass and wing chord, we can use this handy dandy chart to classify the owls as female or male or unknown with a 98% accuracy. This is a table that Brinker and some others developed. And it's so accurate that the Bird Banding Lab authorizes banders to use this chart instead of taking DNA samples, which is a lot more disruptive to the bird and a lot more costly, of course. Okay. Next is my favorite part. We figure out how old the bird is by looking at flight feathers in the wing. So the only time an owl grows all of its flight feathers are going to be when it's in the nest. And so if we catch an owl where all the flight feathers are really uniform, we know that this bird was born this spring and it's a first-year bird or hatch-year bird. But as the bird gets older, they lose and replace flight feathers in a fairly predictable molt or pattern. However, in Northern Saw-whet Owls in particular, it can be hard to tell which feathers are old and which are new, because if you're familiar with raptor banding, we typically use the wear, but mostly the fading of the feather in sunlight to age the feathers. That can be really hard to do when this owl spends most of its adult life in the darkness. So instead, we use a cool party trick, which is that owls actually fluoresce under black light. Saw-whet owls, like a lot of other species of owls, have a pigment in their feathers called porphyrin. and that pigment fluoresces pink under ultraviolet light. The pigment, by the way, also fades with age and light. So we turn off the lights, turn on the black light, and this is what we see. The new feathers fluoresce brilliantly pink, and then the older feathers are going to be pale pink or maybe not even glow at all. So now you have at least one amazing fact to share with others that aren't familiar with this today. Here's an example of a hatch year on the left and then a second year bird on the right. You can clearly tell that on that second year bird, there's a large block of feathers in the center of the wing that aren't glowing quite as hot pink. And that's the typical pattern we look for in second year birds. And then I'll leave this up for just a few seconds to see if anyone has any guesses. I know you're all muted, so you won't be able to jump in with your guess, but you can see if you guessed right. This is what's called an after second year bird. So we can't actually, it's really hard, I should say, to age birds past 2 years. They tend to start having a really irregular molt with no predictable pattern. And so what we're looking for in this bird is that there is a center feather that's also glowing pink. There also appears to be 3 generations of feathers, right? Where there might be a difference between this one and how much it glows, or maybe this one and this one. And so all we can say is that it's after second year. So this is also my favorite part, which is releasing the owl. So when we're done taking all of our measurements, because we have a relatively low number station, so we don't typically get like 200 owls like some other stations do in one night, we're actually able to release the owls individually. And so we take the owl outside, check for predators first, just to make sure that there's nothing in the trees above us. And then we turn our headlamp to red and hold on to the owl for just a few seconds to let its eyes adjust to the darkness, and just put it on our palm and let it go. And it usually takes about less than 5 minutes. And here's an example. There it goes. This is always our volunteers' favorite part too. So one of the most rewarding aspects of this work for me is that I get to share my passion for this work and these birds with other individuals. We have a really small blind, but it's full every night with eager helpers that like to stay up late with me to study these owls. We typically have over 40 to 50 individuals coming through our blind in a season, and usually I open it up to the public and it's gone within an hour. All the slots are full, so I just can't seem to keep up with the demand. It gives us a really unique opportunity to bring people to see science up close, to see a bird that very few people are apathetic towards. And by tugging on their heartstrings, this bird is really helping people feel more connected to nature and to conservation. And that's really, really meaningful. I think many of you here today have had a similar experience, because Project Owlnet stations tend to welcome visitors in the hope that they also catch, as we say, the cute owl virus. If you've caught the cute owl virus just from this presentation, there's a lot of things you can do to help your saw-whet owls next door. This includes, if you have property retaining dead standing trees or snags, this provides really good nesting habitat and habitat for prey as well. You can also install nest boxes. Just be careful not to create like a sink. So make sure that you read about predator guards and that you're creating a nest box that has the right characteristics. You should also avoid rodenticides, which I know is a hard ask when we have pest problems, but more and more the rodenticides that are on the market are slow acting, which means that a lot of the rodents, before they die, get confused and come out into an open area and get predated on by owls, hawks, foxes, and so forth. And unfortunately, we find a lot of our raptors nowadays with levels of rodenticides that are just unhealthy in their system. Also just maintaining a really healthy urban garden. If we all had beautiful native habitats in our backyards, we would provide a lot of really good habitat for these species. And so make sure to create a lot of structure that's really good for fostering a lot of different predators and prey. Preventing window collisions is also a really big one. It's the second highest cause of mortality in migratory birds. And then keeping your cats indoors, another really difficult thing to do because they like to be outside, but cats are the highest cause of mortality in migratory birds. And then lastly, you can turn off the lights during periods of high migration. There's a really cool tool called Birdcast that came out of CSU that is a visualizer for periods of really high migration in your areas. And you can sign up for alerts where you just get text messages or email when there's nights with a lot of birds moving overhead, and you can turn off your outdoor lights during that period so that they can navigate using the stars and not the buildings below. So, of course, it takes people and time and therefore money to make great conservation science happen. We're really grateful to have received a grant from Tracy Aviary. We are looking for additional donations to support our work. Any amount you're willing to give will go a long way. So please tell your neighbors, your friends, your kids, your grandma. I can email a link to our donation page if you're interested in doing that after the webinar, but this QR code on the page will also take you there. And it's still in the corner there. I'll leave it up during questions, but I just want to thank you so much for your attention today. I hope it was enlightening. I know a lot of people on this call are really experienced banders, so hopefully there was some new information in there that you didn't know. But for now, let's have some fun and open it up to audience questions.
Thank you so much, Marion. That really was a super informative talk. Absolutely have to agree with you. The Northern Saw-whet Owls, I think, are just an incredibly charming bird. And my experiences volunteering at banding stations have just been like super exciting and wonderful. And it's also wonderful to see people in the chat talking about their banding stations and things that they're starting up. So we have a few questions. One is from Earl Harrington. He says, what specific months do you do spring and fall migration surveys?
Yeah, so I can mostly speak about fall. So it's very region specific. So for example, like my station, so in Fort Collins, we're located at 5,000 feet above sea level. And so because of that, we tend to see a sooner migration than, for example, Assateague Island that's at sea level. So Assateague Island, that banding station in particular will mostly start in October and go until mid-November, whereas my banding station actually starts in mid-September and things fizzle out at the end of October. So it depends. Our stations in Canada start really, really early, like in August, in mid-August. So in the spring migration, however, to be honest, I'm not sure. Maybe someone on this call is actually doing saw-whet owl banding. I will say that, the common months that we think about spring migration are April and May. The thing that I've noticed about saw-whet owls is they're often behind those big songbird migration waves. And so, for example, we tend to see them a lot later. Like we tend to see the peak of migration a lot later than when our songbirds have already gone through. So I would suspect that spring migration is somewhat similar, but I don't know for sure.
That's super interesting. Yeah, if anybody does know, please feel free to put it in the chat. Julie from HMANA wants to know, you mentioned fall migration is more concentrated. Of the 150 or so stations across North America, how many do band in the spring?
Ooh, that is such a good question. I wish I prepared for it. Yeah, I could get that information and maybe I can do that in the background and we can get back to it because I'd have to look at our station data for that. My guess is 20 or 15% of them do spring migration as well. And a lot of that has to do with whether the banding station is set up for saw-whet owls specifically, or whether it's part of a larger saw-whet owl banding effort. I think a lot of our northernmost stations tend to do more spring migrations because they have so many birds in the fall because that's the primary breeding area for northern saw-whet owls. And so, they get enough that it makes it worth it in the spring to do as well. And they might even do breeding studies as well. That's something I didn't mention, but we don't only, our stations don't only work during migration. If they're located in appropriate areas, they'll also do like nest box monitoring and so forth. So, yeah, I guess I can try to look that up, Julie, in the meantime, but if I don't get to it, I'll get back to you later.
Yeah, great. So Renee wants to know, what impact do the larger owl species have on this species and the study of them?
Yeah, that's a good question. I mean, there's always predator-prey relationships, right? Like no matter what species we study, we always find that there's some predator pressure. So I don't know. I think that's one of the information we don't have is like how much mortality is caused by predation for saw-whet owls. But I would imagine that, they're treading very carefully. And I am very fortunate not to have to deal with this issue, but who knows, maybe I will in the future. But barred owls are a big problem for our stations out east. When we trap for saw-whet owls within the barred owl range, barred owls are just so smart. I love them. I studied them, as you heard, that they are one of the owl species that like kind of hones in on banding activities and will kind of use it as like their free deli. So we have to be really, really cautious of that as banders. And we have a number of different ways that we curtail accidental predation on our northern saw-whet owls during banding. Some of that includes camera, sitting still at the nets so that we can get the saw-whet owls right away, or even closing down the station if there's a barred owl in the area for a number of days until that barred owl moves on. But it's a real issue. So, I mean, they really are chicken nugget sized, and predators are a real problem, which is one of the reasons why you will not be successful in banding northern saw-whet owls if you're trying to trap in an area that doesn't have a lot of dense understory, because they just won't feel safe in traveling through that area.
Absolutely. Yeah. I volunteered in New Hampshire and we had an issue with barred owls, and we would take turns waiting at the nets,
Yeah.
close to the nets, but silent, to make sure that there was no predation happening.
Yeah.
So yeah, I agree.
And it's
I'd
not
like to
just
say
barred
more.
owls, it's eastern screech owls too. I mean, lots of things, but barred owls are just the ones that are, yeah, so behaviorally adaptive that they've figured out that they can just kind of stay put in that area and get more food out of it.
Yeah. So moving on to more questions about breeding. Jerry Toll would like to know, have you put up nest boxes for breeding data?
Sorry, can you repeat that question?
Have you put up any nest boxes for to collect
Oh,
breeding
have
data?
I? Yes.
Yeah.
It's something I actually really want to do because the Front Range is breeding habitat for northern saw-whet owls, but I need to find funding for that first. So I have thought about like partnering with the Boy Scouts and things like that to like come up with the kind of a low budget for getting a project like that going. But we need enough nest boxes that it makes it worthwhile to do a study like that, right? So it's in the works. Stay tuned, but not yet.
Great. And then related to that, David Fitch would like to know, are there nest boxes specifically for saw-whets, or what other bird nest box sizes would be appropriate?
Yeah, so I think, oh gosh, I should have prepared for that question. I think it's the Cornell Nest Watch. Yeah, it is the Cornell Nest Watch. So Nest Watch is a really great resource. You can just Google it. for nest box dimensions that are specific to different species. That doesn't mean that, you know, the dimensions won't also apply to eastern screeches or, you know, invasive starlings. But it can give you some really good guidance about where to place the box, what dimensions it should have, and that's based on real data about natural nest cavities that the owls select for in the wild. And again, I just like to reiterate that nest boxes are one of those things where we think we're helping, and it seems like a really attractive thing that we can do in our backyard, and it is. But it also makes the cavity a lot more visible to predators like raccoons and snakes. That kind of imprint on that visual, like they know something's in there. And so we just have to be really cognizant of that and provide adequate predator guard to make sure that we're not like providing an ecological trap.
Absolutely, that's really important. Thank you so much, Marion. It seems like that's the end of the questions. So I'm just going to say thank you so much again. This is so wonderful. And I'll hand it back over to Julie.
Okay. Yeah, thank you so much, Marion. That was excellent. I will say that it's nestwatch.org. If anybody wants to go check out those dimensions, I highly recommend putting out a box if you can. We have nesting saw-whets here in New Hampshire. They're just you know, here and there. They're such a mystery, such a mysterious species. I've been very excited to help band them the last few years. This is our third year that I'll be volunteering, and just anything we can learn about this species is great. And I'm so glad that you guys are heading towards a centralized data repository. That's exciting. I see a lot of similarities between Project Owlnet and Hawk Count, actually, in kind of how it started and evolved. And Hawk Count, you know, has data from over 200 active sites now across the Americas and down through the Caribbean, and largely volunteers contributing to it. So it has a lot of similarities to it. So yeah, I hope that people will consider donating to that effort. It's so important to be learning as much as we can about these species. And I'm so glad you shared that slide about what people can do. That was really, really important. I'm going to be taking a raptor road trip down towards Assateague Island this fall, visiting hawkwatch sites. So my husband, who helps run the Saw-whet banding station here in New Hampshire, we both just said, oh, we have to visit Dave's banding station down there, hopefully in October.
Yeah, it's a beautiful site. You'll love it.
Oh, good. We'll try and make that happen. But thank you to everybody that joined today and for the great questions, and to Marion for taking the time to share this with us. It's really such a fascinating species to learn about. And just to let everybody know, we'll be focusing our next Lunch and Learn in September on broadwing hawk wintering habitat in South America. We have Diego Garcia is going to be speaking, I think September 18th, but we're just nailing down the date and the time. So stay tuned. Hop on our e-newsletter or on our website. I'll be creating that event shortly. And we know a lot about broadwing hawks up in North America, not as much about how they spend their winters in South America. So he's going to be focusing on that. I'll also mention that our early bird registration for our HMANA conference this fall in Duluth, Minnesota, is coming to a close at the end of this month. So if you're thinking about joining us for our 50th anniversary conference, you can go to HMANA.org and register before the end of August, where the prices will kind of jump up a bit. And just thank you everybody again for joining today and supporting the work that HMANA does for raptors in the hawk watching community. And I hope we can see everybody next month. Have a great day.